In section 3.7, we'll use chemistry's favorite counting unit, the mole. Once we've defined the mole, we'll use it in calculations. Let's begin. How does a dozen donuts sound right about now? If I offered you a dozen donuts, you know I'd be giving you 12 donuts. In chemistry, we use another counting unit to keep track of mass quantities of tiny particles. This counting unit is the mole, and 1 mole of anything is equal to Avogadro's number of units of that thing. This is handy because it gives us a definition to go between numbers of atoms or molecules to moles of a substance. We can use this relationship anytime we're given moles and need to know the number of formula units of an ionic compound or molecules of a covalent compound. Let's work through some examples. How many moles of helium are in a party balloon that contains 2.74 times 10 to the 23rd helium atoms? Here, we'll start with helium atoms, the quantity we're given, and use Avogadro's number to calculate the number of moles of helium atoms. We start with 3 significant figures, so we'll round the 3 significant figures at the end. How many moles of carbon are in 1 mole of sucrose? Do we need to use Avogadro's number? I ask this because once you're given a shiny new tool, the tendency is to use that tool for everything. Keep in mind that just because you only have a hammer, it doesn't mean that every problem is a nail. The subscripts in the formula tell us how many moles of each element are present per mole of sucrose. For this reason, we don't use Avogadro's number, but simply state that we have 12 moles of carbon, 22 moles of hydrogen, and 11 moles of oxygen in 1 mole of sucrose. How many moles of each element are in 4 moles of CCl4, carbon tetrachloride? Try this one on your own, then I'll sketch out the answer. We can use Avogadro's number to calculate the number of atoms in a compound too. For example, 1.20 moles of MgCl2 will contain 7.23 times 10 to the 23rd magnesium ions and 1.44 times 10 to the 24th chloride ions when it dissolves in water. Let's try another example. How many iron and sulfur atoms are in a nugget of fool's gold that contains 0.25 mole of FeS2? As always, I'll leave you with the parting thoughts of the authors.